Good morning. Everyone had a good time at the party last night? Yeah? All right. Welcome to Deep Dive on how the ArcGIS API for JavaScript widgets were built. My name is Matt Driscoll. I'm here with my co-presenter, JC Franco. We are both on the ArcGIS JavaScript team, and we both work on widgets, stuff like that. So on today's agenda, we're going to talk a little bit about some of the things you guys need to know for coding widgets. We're going to talk about how we got to the state that we're in right now with our widgets. We're going to go through our typical development lifecycle for creating a new widget or new functionality and stuff like that. We're going to show off some of the tools we use that help us build widgets, test widgets, things like that. We're going to have some more resources for you guys to go learn how to create widgets or do things like testing and making better widgets. And then we'll have some time for some questions and answers at the end. So some prerequisites. Our API, kind of the foundation of our API is our core accessor class. And this class easily lets you set and get properties and things like that. So this is a key class for creating widgets, among other things in our API. So knowing how to use and implement accessor is going to be a key thing. So what it does is it allows us to have a consistent developer-friendly API across our JavaScript API. And if you want to know more about accessor, I would suggest watching some of the videos from accessor presented here at the conference and going to our ArcGIS JavaScript API SDK pages, going to the guide, and implementing accessor topic here. Another big one is TypeScript. So our new widget framework is, or base class is implemented using TypeScript. So you're going to have to be somewhat familiar with that to be able to use it. TypeScript is just a superscript of language for JavaScript. So it's just adding on to JavaScript, and you can compile it into JavaScript with options targeting whatever version of JavaScript you want to. And it kind of allows you to use some of the newer features and functionality of JavaScript right now and be able to write a little bit more easier code, a little more legible stuff, and write a little quicker. So this is the ES6 stuff I was just talking about. Also, it lets you be able to define interfaces. And obviously typing is a big part of TypeScript. So you can declare what kind of type a variable is, so that if you set it later and you set it to something that it's not supposed to be, it can catch that at compile time and let you know. So it's a big part in stopping bugs, basically. It'll save you time later. So one of the main things, you're not going to be using var in TypeScript. You're going to be using const or let. So you're defining things as a constant or letting something equal something temporarily, which is probably more like var and what you're used to. Also, we have these fat arrow functions, which is a lot easier way to create a function, like an anonymous function, instead of typing function blah 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 and then binding it at the end. So this is a pretty handy thing in TypeScript that we use a lot. We also have a nice TypeScript setting up guide here on our SDK page. So if you go to our guide topic again, scroll down, we have a TypeScript setup right here. And it'll walk you through getting your environment set up for TypeScript and installing our typings. And we also link to Dojo typings if you want to install those as well. Kind of how things are set up with the folder structure, how you compile, and stuff like that. So it's pretty helpful to be able to get you guys started.
So I wanted to add something. So TypeScript, it's really useful because it allows you to program and catch errors early on. So there's a lot of options that you can use to kind of leverage JavaScript features that aren't implemented by all browsers yet, but it allows you to, when it compiles, the built JavaScript will be in something that your target browser would understand, and you can configure this however you want. So the constant let are really useful. Extending on what Matt just said is, you can still use var, but I know it's happened to me where you have a variable and then it's originally used to be a constant, and then later on you assign a different value, and you may not want to do that. Constant let protect you against that because they differentiate between something that's constant or something that's going to change in value later on. But yeah, that's pretty much it. If we have time, we'll show a demo of how to set up your environment to support JavaScript API with TypeScript. And also, there is a session right now going by Rene that is covering using TypeScript with the ArcGIS API for JavaScript. So make sure to catch that video later on when it's published. Cool.
Thanks, JC. All right, so let's talk a little bit about how we got to this point. So in Prereqs, we were using mostly Dojo Digit for our widgets, and Digit has their theme library, and also their widgets are kind of tied to the user interface. So if you wanted to theme Dojo widget, you had a few choices out of the box that I'm sure you guys are probably familiar with. But if you want to do something custom, it was kind of hard and complicated to do, and you'd have to pretty much write a lot of code for the whole set of widgets. So now in Prereqs, we have more of an abstracted framework that's kind of independent of whatever. So you guys can use whatever framework that you want with your widgets. And we have the logic separated from the view. So we have these things called view models, which do the core functionality of the widget and kind of handle the data, provide a nice API, things like that. So you can easily add on to these things or use them and create a totally different view for your widget. So why did we do this? We wanted to be more framework independent and let you guys take some of our widgets, and if you don't like the current interface of it, you can rewrite it easily to fit whatever framework you're using and use your own classes for it and stuff like that. We also made the themes very easily customizable using Sass. You can go as deep as you want with them. You can just tweak some variables and get a different color scheme and font sizes and stuff like that. Or you can go deeper and actually start tweaking layout stuff. We also had all of our widgets designed with responsive design in mind, so that we changed layout and things like that and sizing depending on the browser size and also the view size. And we went ahead and redesigned some of the APIs of our widgets, some of the method names, some of the properties that you guys can watch, events, things like that. And we did this to be more consistent with the rest of our API, so that most of the stuff you really don't have to look at the docs to kind of figure out. It's pretty consistent across the widgets and the rest of our API. So there's less guessing involved. It'll be a little more friendly for you guys to work with.
Adding to that, so Matt mentioned Accessor, which is the foundation for most of the JavaScript API classes. So we already had a base for class, so we wanted to have something that continued and adhered to the developer experience that was being set by Accessor itself. So that's another reason why we introduced this new widget framework. So we already had the component part of it, so we just wanted to have something that took care of the rendering and made it easier to reason about when you're editing or authoring your widgets in terms of updating the UI, making it look the way and behave the way you want.
Yep. So now I'll go into our development lifecycle and kind of talk through how we go about developing a widget kind of from scratch, I guess. So we usually start out with some kind of API design, and we'll kind of do this by writing something on a whiteboard or sketching something out, and then eventually kind of the API will make its way into some kind of a markdown document or a JS doc, and this is kind of where we're defining all the methods we need, what this widget's going to accomplish, what properties people are going to be able to watch, what events need to be fired if necessary, things like that. And this will be in some kind of a living document where we kind of refine it and get it to where we want it to be, and so that it'll fit within our API. Next, we kind of kick off a UX UI design discussion and kind of bring them into the fold there and kind of get their feedback on what this thing should kind of look like depending on the data and the methods we have, and explaining all the use cases and how the data is going to be, like what's the most common formats of it. And this will kind of guide them to figure out how to display this thing. Once we have that, we kind of start developing the view model, which is more of the data side, writing that, getting all of the methods we defined earlier and properties implemented. Then by this time, we kind of have like a basic design that we can kind of put in a prototype. We get the view written, decide which things the view model we need to alias on the view as well, so that if someone wants a property on the view that is also on the view model, we can kind of pass that along. We decide which methods need to be public on just the view model versus the view, things like that. Then we go ahead and we're getting closer to being more solid here. We start writing tests to test all the functionality of both the view and the view model to make sure that everything's working as expected for all the different scenarios where people pass in different arguments, methods return different return types, stuff like that. So we have all the tests, we have all the view and the view model code written now. We go ahead and open up a pull request using GitHub Enterprise is what we use. And then we get that all situated so that the rest of our team can kind of review this and check the code, offer feedback, stuff like that. So it goes through that kind of lengthy process of getting the code to where it's in a quality state. Once it's there, we can then merge it in and do more testing using samples and stuff like that. So kind of the API design. Basically, what this is a sample of what kind of a developer would write for a widget. I think I did this one for the pop-up. I kind of had like an objective of what this pop-up was going to be like, and this is for the Prereqs API. So I had some goals in mind, objective of what I wanted the pop-up to be able to do. It needed to have a better DOM structure, be responsive, things like that. I had some basic requirements that were given to me by my supervisor and I guess user requests, stuff like that. I had an issue on our Devtopia, which is our internal GitHub page. And I had a list of stakeholders, people that were involved in making some of the key decisions and responsible for the success of this widget. I had wireframes, but the image isn't there right now. I had a basic demo prototype. And then I kind of started defining the, the constructor, some of the properties and arguments that could be passed to the widget, all their different types, descriptions, if they're read-only, if they had default values, things like that. And then what kind of methods it needed to be able to, for a user to interact with it, what events needed to be there. I had some example snippets of how someone would kind of use this widget. And then we had a bunch of, I kept a list of all these questions that other developers were asking about this widget, and we kind of went through them and solved them through meetings and stuff like that. So I had like a bunch of like questions people wanted to try to figure out about the pop-up. And we kind of kept track of all those things and then notes from each meeting and stuff like that. So that's kind of how we worked through getting a refined API for a widget. So kind of go through again, we had the view and the view model kind of defined, what properties, methods, events, sample code snippets, prototype demos, questions, and we kind of just worked through this document to get it to a state that we needed it to be. And once we had a more refined version of that, we put this into JS doc, into our developer pages, basically, on like a local testing environment. So some things about the view model, and when you're considering design, you should have friendly, consistent naming across your widgets. Complicated method names that don't, kind of mean anything aren't going to be good. You should consider what methods need to be public, what they need to return when called, if they return a promise or some kind of an object or something like that. What arguments they take. One thing we tried to do now is just pass in one argument as an object so that if it grows too much, we're not having this super long list of arguments that becomes really complicated. We try to consider what properties need to be public or internal, private properties. And for the view model, we make sure not to have any view UI logic in there. So it's just handling data, API, things like that.
Yes, and so the view model its main task is to provide the view the support for it to render the way you want it to. So once you define your APIs inside of your view model, you can go further and extract your code into reusable modules and that you can use somewhere else. So the view model is just kind of like to support the view, abstracting all the core logic of it. Inside of it, you can pretty much you can either just keep all the logic there if you want, if it makes it easier for you, or keep extracting and making your code more modular.
Yep. And the view is kind of opposite of that. You want basically the view to just handle the presentation of the widget. So for our views, we'll research like a DOM structure that we need to be able to accomplish the goals of the widget. So we'll consider things like layout, what things need to be presented. We try to use proper semantic tags for what they do, so that if the CSS wasn't there, it should be pretty apparent what this widget does, and it'll make it a lot easier for people with accessibility issues to be able to use, and just make it more semantic for like search engines, stuff like that. We also use a CSS object, which we'll show a little bit later, where we put all of our classes in a JavaScript object to kind of keep them in a nice place. And then we use that object in our render method, which will basically take those classes and put them into HTML. We want to make sure that we be accessible where we can and use ARIA roles, which define elements as what they should be doing. And I mentioned a little bit earlier about aliasing properties, but we want to make sure that anything that's defined on the view model that needs to also be on the view, so a user can just listen to the view instead of having to dig into the view model, that those are aliased. And make sure there's no API logic in here. It's just dealing with presentation of the view model. So some styles. We want to make sure we have all the classes we need, that we're naming these classes consistently. And we use this methodology called BEM, which is block element modifier. And I'll get into that a little bit later. But it helps us name classes in a consistent, friendly way, so that we're not basically all doing different stuff on our team. And some of the big keys about styles is our Prereqs widgets can use some of the newer styling techniques like Flexbox. And so that saves us a lot of JavaScript code and makes it a lot easier to write widgets. So when we are designing a widget, we meet with our creative lab, which is responsible for the UI, the UX, and accessibility, stuff like that. we kind of discuss our needs and we show them the API. And we collaborate on designs and tweak things as necessary as we learn, things need to be presented this way, or the data may come back in a different format than you guys were expecting, stuff like that. And then eventually we receive some kind of a mock-up, and then wireframes, and then eventually assets like images and stuff like that. And sometimes we even receive Sass from them so that they want certain styles and things like that. Then we implement that design in our widget. So part of the testing, we make sure we have tests that hit all part of the API of the widget. Means we make sure that the properties are all covered when they change, methods are called, return types checked, stuff like that. We do tests for unit tests, integration tests, functional tests, and screenshot tests we're still getting into a little bit, but we use some of those. We make sure that everything is working basically, and we start doing that early so that if we catch errors, we're not going to find them later, we're going to get them up front, and it helps us a great deal.
Another benefit about testing early is it can help you kind of catch issues in API design. So you could start writing a test even if your class doesn't exist, and you can kind of get an idea of how the final API is going to look like and behave. So based on that, it can help you better shape some of your classes or modules. The other benefit about testing is if you also include that and have some sort of continuous integration, you can run. For example, in our team, we have a setup that will run the test suite every time there's a commit to the master branch or any other of the, actually it's any other branches. It'll run a test for each one of those that is involved in a pull request. So it's a really nice way of making sure that you're writing code and later on you're not introducing regressions.
Yeah, I should mention it once we have the PR open for one of our widgets. Before we merge, we'll make sure that the build is successful and that all the tests are working as expected. So it really helps us instead of just having, like samples or stuff like that. So yeah, we make sure all the code changes done in a Git branch. We then open a pull request with all the changes and unit tests and functional tests, all that stuff. And then we have other members of the team that are kind of within the same scope of work review it and test it. And we have the design team look at it. We run like tests for accessibility, and then we merge it, and then it's in. So I'm going to turn it over to JC to talk about some of the development tips.
Thanks, Matt. So in terms of development tips, we're going to start with the design. So one of the things we did in 4X versus 3 is we took it as an opportunity to kind of revisit some of the existing APIs we had and try to make sure that all the APIs are consistent with the rest of the widget. The widget APIs are consistent with the rest of the API, essentially. So in order to support this, we already have some very useful classes that we can take advantage of. So for example, Accessor is pretty much the core of all of our classes. And just by using Accessor, it gives us a really nice access to a really good set of features. For example, you can watch for properties. Any properties you define on your widget or your class, anything that extends Accessor is watchable, so you can see track if it changes. Whereas in 3X, you had to the pattern we had was you had to emit an event and then make sure to that was the way you got notified if a property changed or not. Another useful one is collection. So before, if you had arrays, if you wanted to be notified whenever the array got modified or if items are added or removed, you had to do this by wrapping an array and providing some sort of API, add or remove APIs. But now collection gives us that nice functionality, and it's also accessor based, so we can watch for the properties. So it also emits events, so we can know when properties are added or removed, and react accordingly. As I mentioned before, in 3x we relied a lot on events for when to be able to know when properties changed. In 4x, it really cleans up a lot of the code because it's already built in since we're extending accessor. So that's a really nice one of the key features. So for each of the properties, we can define the way they behave. So if you want a property that you want, it's supposed to be set internally only, you can mark it as read only. There are some other ways of configuring your properties. It's covered more in the accessor session. Another thing that we do more and more is whenever there's some sort of asynchronous operation method, you can use promises, and it really makes for really neat code that you can write, and it looks and reads like synchronous code, but behind the scenes it'll take care of all that asynchronous operation and let you know when the operation succeeds or fails, and then you can just based on that, you can adjust your code flow and then decide what to do with it. As I mentioned earlier before, we'll also do more and more support modules. So anything that we can extract and make it into its own separate small module and test it and then reuse it somewhere else, we do it. And it's really becoming more and more useful as we have common behavior that's shared between widgets, so it's really nice to have a module that we can just import and reuse. So now I'm going to talk a little bit more about the actual rendering of the widget. So if you attended one of our previous sessions, we went into how render is one of the key methods inside of widgets. So now this is the main method that you need to override and provide your version of it. The goal of it is to define the UI of your widget. So render contains everything, will contain the representation of what your widget will actually look like. So one of the things that is really useful now is when if whatever render returns is actually going to be generated in your DOM. So before, if you wanted to hide a node, it would be a matter of toggling some sort of CSS class or using an inline style to hide or display the node. Whereas here, we can just decide to not render the node at all, and then the widget framework will take care of not displaying that node. So that really cleans up the CSS aspect, so we no longer need to have some sort of specific class to toggle elements on or off. So in this little snippet, I have a child node, and if I want to display it, I'll just create its DOM node representation. Otherwise, I just use null, and then I return that. So whenever the child is visible, the rendering will take care of displaying that node. Otherwise, it just doesn't get created at all.
Yeah, so this assumes that the child visible is a property on the widget and it has a renderable decorator. So basically it watches that property for changes and then will re-render this DOM based on that property's value. So you can see the child visible. If it's visible, you're going to get a div with child in it. Otherwise, you're going to get nothing.
Thanks for that. Yes, as Matt pointed out, so the render method can get called multiple times within the widget's lifecycle, and the framework will take care of actually rendering it when it's necessary. So if you're calling render multiple times and properties aren't changing, that won't produce anything in the DOM. It'll still keep the same structure you had before, because now it's a little bit smarter and it knows, okay, no properties changed, so I can just keep the existing rendering. The next one I want to talk a little bit is if you looked at some of the examples we've shared, you'll see this kind of CSS object, and it's Matt talked a little bit briefly, and he'll cover a little bit later. Is It's a utility we use to kind of keep track of all of our classes and make it easy to reuse. And so instead of being error prone and using the strings, we just use this lookup object. When you're in your render method, if you have some logic in your widget that will cause some classes to be added or removed dynamically, you would use the classes attribute, and the way it operates is it expects an object with the first with the key being a CSS class, and the value is either true or false. And if it's true, it's going to be appended to the node, and if it's false, it's going to remove it. So whenever this is disabled, property is true, it's going to apply the class. Otherwise, it's going to remove it. Having said that, it's good to know that if you use class for your node, whatever you set class to be can't change at all. So render expects class to always be the same class, the same value. So if you ever change it in a different render call, it's going to cause an error. So that's one thing to look at if you're developing your own widget. So in this little snippet, based on some random condition, I'll decide whether to use one or foo or bar as a class and try to assign that. But I get an error on the second one because on the second render call because I can't change that. It's expecting class to be static. So if you have multiple ones that you want to apply and you're utilizing our CSS lookup object pattern, we have a utility to kind of join all these classes into a single string. If you weren't using the lookup object at all, you can just give it a regular string with all the different classes that you want to use. It's the same thing, but this is kind of a helper for our pattern. Similar to classes, if you have styles that need to change dynamically, there's a styles attribute that you can use, and it expects an object with the key being the style property that you want to set, and followed by the value. One thing to note that is whatever attributes you provide in your rendering, they can't change. They'll always remain there for the lifespan of the widget. So if you have some sort of tab index value, you set it to 0, and later on you want to remove it. Before, I believe in Prereqs code, you would, or if you used a Dojo DOM style, you could set the style to an empty string or a falsy value, and it would remove it. That approach won't work here because renderer expects that whatever properties you give it, it's going to stay the same. So you are in charge of managing that. Another key thing that might be useful is using string templates. Since we're using TypeScript, we can use string templates, and they allow us to write readable code and be able to reference variables inside of a string. So this is the actual template itself, the hello person name, and that's the syntax for referencing variables, the $, and then curly braces. So it really helps us kind of build strings and keep them readable without having to worry about breaking. It supports multi-line too, so if you wanted to break it into multiple lines, you can do it and still keep it readable, and TypeScript will take care of it when it's compiling into JavaScript. One key difference is that if you have children in your widget, siblings, that will be added or removed, you need to provide a key attribute to make sure that the rendering framework knows which child it's being added or removed and not mess with the siblings. So in this example, I have my parent node and I have 2 siblings, but they're static. They won't change at all. So if you look at the render method as a whole, it's always going to return the same thing. So key is not necessarily, it's not needed. Whereas here, if I have some sort of condition that determines whether each one of these items is displayed or not, that's where I need to provide a key attribute. So that way the rendering framework knows, okay, this item is still visible in the next rendering, so I'm just going to keep it. So it's one thing to look for. And note that key can be a string, a number, or an object, so you're not limited to strings.
Yeah, if you run into an error with this, it's anything with key. Realize that it's a virtual DOM, so when it's removing these things, it needs to know which one to remove. So it's mainly when you have siblings. So you have two divs that are in the same hierarchy or two spans, something like that, and you want to remove one of them by a property or something changing. Then make sure that those two siblings have a key assigned to them.
Thank you. So if you want to pass data or some sort of object into, I should step back. So if you look at the snippet, I'm providing an on-click click handler to the on-click attribute. So whenever the DOM gets clicked, it's going to call this the handle click method, and that's the way you would react to DOM events. So if I wanted to pass along a value to the handle click method, the way you would do it is by providing your own custom attribute and referencing it within the handler itself. So in this example, we've adopted a pattern where we prefix all of our custom attributes with data dash. So in this example, the lucky numbers are passed, and it's an object. Actually, no, it's an array. You can imagine it's an array of numbers. So whenever the user clicks on this node, it's going to execute my handle click method. And the way I get back this object is by getting the attribute directly on the node. So any custom attribute that you set on your rendering, it's going to actually get added to the node. So within your method, you have access to that object. So it's just a matter of calling node.getAttribute, and then the name of the corresponding attribute. That's how you get your custom data.
Yeah, I should add that the custom data attributes are HTML5 data attributes. So adding them is not going to be like an invalid HTML or anything like that.
Binding is another thing to look out for. So in this example, I have two nodes, and they both call the log this method. And in the first example, when I click on the node, it's going to execute my method, and this is going to be set to the actual element. If for some reason you wanted to change that and have it reference your element itself or the widget or some other object, if you wanted to change the context of this, you would use the bind attribute. So in the second example, when I click on my node, the log this method is going to call, but the value of this is now going to be the instance, the widget. So this should have gone earlier, but the way you handle DOM events is by using the corresponding event attribute on your node and passing a function. Functions similar to a class cannot change between renders, so it's one thing to note and look out for. So whenever a user clicks on the image, it's going to call the handle click event. And the event you get is the DOM event, so you can treat it as, you can access the real DOM node if you need it right there. Having said that, one of the main differences here is that render is virtualized, so all the markup that you use and all the children that you create within your render method are not from the real DOM. It's a representation of what your UI is going to look like. It's virtualized. So if for some reason you needed to keep a reference to one of the actual node that it gets assigned to your rendering. You can use the after create or after update methods, which get called as they read, essentially. So after the node gets created, it'll get called, or after it's updated based on our following render call. And what you get back is a node, and you can store this, and then if you need to do something else, you can do it.
Yeah, one of the main times we kind of use this is for focusing a node, since we need to get access to the actual node to call focus on it. If we want to like move to a node and focus it after someone selects something, this is what we would kind of do to do that.
So for widgets, we have this decorator, which is it helps us provide a handler that can be reused for clicking and when you have key down events to respond to enter or space. And it's something good to know, because if you didn't have that, you would have to wrap the method and have it react differently versus when it is called via a key event versus a mouse event. So it's just a helper to reuse methods on click and key down, and specifically for our widgets, making them accessible. If you have a focusable node, if you want to make sure that it does something on click as well as space or enter, this is one way you could do it and simplify your code. One kind of neat thing to know is that if you have childless nodes, you can just close the tag to keep it simpler. Less code, so just a small tip. And as your render method, depending on your UI and your widget, your render method can vary in size. So one thing to keep in mind is, or a good practice is, every once in a while assess whether it's getting too unwieldy, and if it is, that's where extracting parts of it into helper functions can be useful. So in this case, I want to render my content, and I have this other function that takes care of generating it, and I just return. It's pretty similar to render. It's returning a representation of your UI. So we've talked about this before, about when you're thinking about how to do your view models. It's a good point to think about the APIs and make sure that you expose properties that are truly needed or named a consistent way. We mentioned before, we're leveraging more collection and accessors wherever possible to kind of make it easier and provide that consistent experience. We extract support modules wherever possible to promote modularity and reusability, make it easier to test. Autocasting is also, we didn't talk about this before, but it's one of the benefits that you get with Accessor. If you mark a property to be, if there's there's a way of a feature called autocasting where it takes care of instantiating a specific type if you pass an object to a property instead of creating an instance and setting the property. You can learn more about that in the Accessor SDK or the session, which we pointed to earlier on. With that, I'll pass it back to Matt.
Thanks, JC. So in the Prereqs of our API, we had CSS, and now we're using Sass to kind of make it easier to theme, take use of variables and mix-ins, stuff like that. So it's something I wanted to note. We have an SDK page set up for working with our styles. So if you go to our guide again, let's go down to styling. We have where you can find the default style sheets. We have the main, which has everything in our API. If you don't want to include any of the widget stuff, you can just grab the view one. We also have a list of all the default out-of-the-box themes that we have. So a lot of RGB style colors in light and dark. We can show you how to customize CSS by just using CSS and overriding stuff. but also using Sass and kind of redefining variables. And you can basically create your own theme and host it yourself so that you can, brand your maps and views as whatever you want to. So there's some additional information here for setting that up and using it. There's a Sass's page if you guys want to learn more about Sass and how to work with it. It's a CSS preprocessor. So you write stuff in Sass, compile it, and then it goes into CSS. So you can have it like minified or do certain things with it. And it really helps like catch some of the CSS errors too, which is nice. BEM, this is the methodology I was talking about. Now I have a slide about it in a couple seconds. This is basically a standard for us to writing and defining classes. It makes things a little bit easier, modular, flexible. It's just like basically a naming practice. Kind of go in here. I want to also mention we have an icon font to kind of keep icons consistent throughout our API. You guys can use as well. So there's a bunch of like different symbols that you can use, and since they're a font, they're SVG and they're scalable, and they'll just they can be whatever size you need them to be. So that's also available under our guide, working with the API. So again, Sass preprocessor. Some of the cool things it includes are mix-ins, basically a way to kind of group statements together and reuse them throughout your application. And you use mix-ins by creating the mix-in and then including them inside a CSS statement, basically. You can also use import to kind of split up CSS files in a more modular fashion. And you can extend classes, basically inheritance, using the extend for Sass. So if I want some class, but I just want to add one more value to it or something, property statement, I can do that. So basically it just gives you more power. Makes writing CSS a little easier. Just want to mention how to install it. This is what we use. We use grunt Sass for us, so we just do npm install grunt Sass like that. There's also a guide page here on that, on how to set that up. Also the Sass, if you don't want to use grunt Sass, there's other options for installing. So you go here, you can use like certain applications will do it for you, or if you're more inclined to use the command line, you can do that. Kind of shows you how to get it set up on different environments. This is the examples of the BEM methodology I was talking about. So for a widget, we'll have a name. For example, this is a widget, example widget. This is our block. And then inside of this widget, we'll have something like an input element. So this will be one of our block elements. And we'll have like a submit button. So this will be our submit button. And as you can see for the elements, we basically just have 2 underscores and then the name of the element. And then if we want to modify one of the properties of the widget, we would just do 2 dashes and then the modifier. So this would be used for basically like applying another style on top of something else, modifying the look of it. And then here's another example of a modifier on like the submit button down here. So if I wanted it to be disabled, this is kind of how I'd write the class to do that. And kind of what you get out of this is it provides semantics. It keeps specificity really low. So you're not going to have any like naming conflicts and stuff like that. And everything's scoped. So it's a lot easier to work with if you want to like restyle stuff. Here's another example of the CSS lookup object we have. So in my JavaScript, I would have a CSS constant where I define all my classes, and then I can use them in my render function or method and return them in this JSX format. So if later on, if I want to change the name of my widget, I don't have to go searching through my file looking for all the places I assigned classes. It kind of just makes it a nice, easy thing to save you time later on if you want to change stuff or add classes. You're not have to writing them more than once. You just have them all in one area. We have some tools we use. We're going to go through some of the IDEs we use. I'll go through what I use. JC is going to talk a little bit about what he uses, and some tasks, and then what we use for testing, and other little things. So IDEs, I use Visual Studio Code. JC uses WebStorm. I use a bunch of plugins for, well, not too many plugins, but a few plugins for Visual Studio Code. Some of the plugins I use are a Beautify plugin to kind of help keep my code look pretty. So when I create a new file, I can write my code, and if things aren't indented the way I want, I can basically do a command of Control B, whatever, and have the whole file be formatted correctly. This kind of is nice for me because I can define what kind of settings I want for indentations, things like that. We also have, in our API, we have this JS Beautify file that kind of configures how our IDEs should, basically be set up for indentations, tabs, like new lines we should preserve, stuff like that. So this way when we have multiple developers writing code, we're kind of using a consistent format, and so it looks pretty good when we're all opening it up. Kind of within the same thing, we have an editor config, and a lot of these plugins are kind of available from multiple IDEs. And this one's pretty simple, but it just kind of sets like what kind of indentation style we should use, what we should do on new lines, if you should trim trailing white spaces, stuff like that. Also, our ESLint configuration, we have a file for that, and that kind of defines how we should validate our code in our API across the board. So this one's a little bit longer, but has all the configuration options for ESLint. I also have this project manager extension that lets me easily open projects real quick. So if I want to switch between different versions of our API or different apps, I can do that pretty easily. This one's pretty handy for if I have settings set up on Visual Studio Code for my Mac, but also at home I have a PC, so this kind of syncs those together. And then just a plugin for like icons, pretty straightforward. So that's kind of my IDE. I'm going to turn it over to JC. He's going to talk about what he kind of uses.
All right, I'm biased. I love IntelliJ. I use IntelliJ. I like it because it's very customizable. I like doing stuff with the keyboard instead of the mouse whenever possible. So I really like that. You can do pretty much a lot of things, and you can look up different commands just via text search. So I don't need to go through menus. And all these are customizable, so it's really nice. I think it's a really nice feature. Plugin support also has a ton of plugins. You can browse for more plugins. Very extensible. The support is very responsive, so I definitely recommend it if you like being it's a little bit more heavy than Visual Studio Code, but I like it. I think there's a lot of benefits there. That's it.
Okay.
You mean the IDE? It's IntelliJ IDEA or WebStorm.
Cool. So now we're going to talk about tools a little bit and kind of the tasks we use. So we use Node and NPM for a lot of our stuff. We use Grunt for our tasks, and we have them set up to compile TypeScript and watch folders and compile Sass, stuff like that. For testing, we're using Intern, and so we can write our tests in JavaScript, as that's what we're kind of developers we are. You want to talk about Jasmine and QUnit?
Well, these are other options. There are a lot of testing frameworks, but some of the most popular ones are Jasmine, QUnit. Karma is really nice too because it's a test runner, so you can configure whatever testing framework you want, and then Karma will take care of. You can set it up so as you're coding, it'll detect changes and then run your whole test suite automatically. And then if you have it set up a certain way, you can even have it live reload the page as you make changes and keep track of stuff. So make sure you don't break things.
Yep. Other tools I use SourceTree for basically Git managed GitHub and Git stuff like that. JC is more inclined to use the command line. As an organization, we use GitHub Enterprise. We do a lot of communication on Slack, and we use a handful of browsers for testing, and then a lot of coffee too.
A lot of coffee.
A lot of coffee. So additional resources for the session. I have some code snippets on here under JC's GitHub account. If you guys want to check that out, just go to GitHub/JC Franco and search for the Prereqs widget snippets. Some good Prereqs stuff there. Pretty handy.
Yeah, you'll find stuff similar to the snippets we showed in the renderer function. To kind of, the idea is to have focused examples or snippets to do different things, and we'll be adding more. I'll be adding more to that.
Cool. Other JavaScript sessions, most of them are already taking place, so be sure to check out the videos of them. And then our documentation pages, I'm sure you guys are pretty familiar with that. Just if you want to get there quick, just go to js.arcgis.com. It'll take you to the Prereqs API page right off the bat. If you guys want to get this code on GitHub, we had a short link somewhere. But basically, if you go to JC Franco's GitHub page, it's going to be Widgets Deep Dive. I think I can, let me find it. Oh yeah, let me copy this link. The short URL is, copy link. Yeah, there we go. esriurl.com/deepdive. And with that, oh yeah, please take our survey. Help us get better at presenting, and we want to know what you guys think, what we could do more, what we could do less, stuff like that. And with that, we'll take questions. We have, I think, about 3 minutes. Yes. Do you want to expose that information?
Yeah. So we're using Maquette. It's yeah.
Yeah, it's what Dojo 2 is using too. Yes. Yeah.
For generating the JavaScript, generating CSS, still readable to readers for internal code. I never use a TypeScript, never use Sass. So I want to work for generating still readable.
So is the question if the final CSS or JavaScript, if there's a way of making it readable, or?
There's options you can define, but I mean most of the time it's compiled code, but you can define it to be more readable, or you can define it to be minified. So there's options you can do when you're compiling.
You can also have source maps. So if I enable source maps and I have TypeScript and I'm debugging my JavaScript code, which is compiled and it's not as readable, the browser will know to, at least I know Chrome DevTools does this, it'll know to map the compiled JavaScript code to my TypeScript. So that helps me kind of debug in the readable source file versus just going through the compiled JavaScript one.
Yeah, so you can still debug it in DevTools basically, because it'll map it automatically.
Same thing for Sass, right?
Yeah, same thing. Sass. They both have map files that the DevTools will use. Any other questions? Right here. Nope. Okay, thank you guys.